Alright guys, welcome to Vectors. Sorry about the glare, but that's what happens when you don't have your own room to record. So vectors consist of both magnitude, which is the length, and it contains direction. It has direction. So there's two things we're looking at for vectors, magnitude and direction. There's only two numbers we need to worry about when we look at vectors. The directed line segment AB. So let's think about being in the coordinate plane, and here's point AB. The directed line segment would be considered a vector. It has length and it has direction. So if we look over here, and I'm going from the origin out to my point AB, it's no longer written with parentheses, but greater than or less than sign. This is actually called component form, and we'll talk a little bit about that. So this would be our vector. It's got direction. So think about north, south, east, and west. Think about going northeast there. It's got direction, magnitude, length from the tail to the head of the vector. That would be a length. And so that is what we talk about when we talked about a directed line segment being a vector. Several definitions we're going to be looking at. A two-dimensional vector V. So we denote vectors with a lowercase letter and like a ray, okay? In a textbook, it's going to look bold. It's just going to say U, V. It's just the variable is going to be bold. So that's how most textbooks handle the way a vector looks. Okay, so a two-dimensional vector V is an ordered pair of real numbers in component form AB. So component form. Okay, we'll talk about that. Now, component form, if you look down here, when it's a standard form of a vector, AB, there's those less than, greater than signs. It means the tail starts at the origin and goes out to some point AB. That's component form. The tail must go through the origin and then travel anywhere, wherever that other point is. But that's component form. So vectors don't have to be in component form, but when they are, they're written like this, and the tail starts at the origin and travels to whatever point is out in the coordinate plane. Again, the magnitude of a vector is the length of the vector, which always has to be positive, so we think absolute value. 0, 0 is called the zero vector. The zero vector has no length and has no direction or magnitude. Okay, excuse me, no length or direction. So it should say no length or direction there, so not magnitude. Two vectors are equal if they have the same magnitude and the same and point in the same direction. We'll talk about this in our example. So just some definitions we got to think about. Okay. Now, what happens if a vector is not written in component form? What happens if it's over somewhere in the fourth quadrant? Well, we can figure out what a vector is in component form by using the head minus tail rule, HMT. If an arrow has initial point x1, y1 and a terminal point x2, y2, it represents the vector x2 minus x1, y2 minus y1, almost like slopes, right? Okay, x2 minus x1. So that's how we get it in component form. The initial point is the tail, the bottom piece. The terminal point is the head of the vector where it ends, okay? So this rule converts vectors into component form. So let's look at one example of what vectors are and seeing if they're equal. So in our example, show that the arrow from r equals -4, 2 to s equals -1, 6 is equal to the arrow from p equals 2, -1 to q equals 5, 3. So directed line segments are vectors. So here I am. I put my vector here and here. There's from p to q. Okay, 2, -1 to 5, 3. And r to s, -4, 2 to -1, 6. So they appear to be going in the same direction, and they almost look like the same length. So we want to know if they're equal. So they're two different vectors. We can tell if they're equal if they have the same direction and magnitude. So let's put them in component form. Okay, so then we can see if they're equivalent. So by the head minus tail rule, directed line segment RS in vector form, component form is x2 minus x1. So x2 minus x1, so it's -1 minus -4, comma, y2 minus y1, 6 minus 2, which is here, which gives me the vector 3, 4. So we'd start at the origin, go out 3 over, and 4 up. There's where RS would be, 3, 4. X value, Y value, tail starting at the origin. Now let's see if the directed line segment from P to Q is in the same spot. Again, to write a vector in component form, it's x2 minus x1, comma, y2 minus y1. So x2 minus x1, so it would be 5 minus 2, comma, 3 minus negative 1, which I wrote here, and I get 3, 4. So not only are they the same length, they're going the same direction, 3, 4. So these two vectors are equivalent because they have the same direction and same magnitude. And we put them in component form to help us out. So that's an introduction to vectors. Later on, we're going to see how to find the magnitude and look at vector operations. If you guys have any questions or comments, let me know. We'll see you next time.